We're at gotomath.com working some calculus. Let's go down to Rules of Differentiation. And 5-3 is the one we want to look at. So we're talking about the quotient rule. That's what we're doing, learning on. Let's write this down. I'm going to write it down so I give you time to write it down. We can all write it down and get it down, right? So we have y is equal to 12 over the square root of, and it looks like I'm running out of ink on another pen. My gosh. We're out 50 pens this week. 15, I know. 15, 16 now. What are we doing? Forgot what's going on here. Oh my gosh. What ink? Blue ink? Let's do blue ink. How's that? Some blue ink. The virtual ink. Some blue light. I wrote this down on a piece of paper with 1,000 formulas on it. Now I can't find it. There it is. Y is equal to 12 over, whoa, that's a straight line, the square root of, and that's not a straight line, 12x minus 6. So we're demonstrating the quotient rule. Right? And the way it works is, let's say we had h of x, we're leaving off the of x part, and k, and we want to take the derivative of this, so this becomes f prime is equal to h prime times k minus h times k prime over k quantity squared. Alright, so these are all functions. Okay, first thing we're going to have to do here though is we're going to need to rewrite this thing. And you know what? I'm going to actually work this a couple different ways. We have a constant up in the numerator, and there's an easier way of doing this problem when there's just a constant up in the numerator. Whoa. I don't want to do that yet. I just want to write y. We're going to rewrite this as 12 over. We're going to get it out of radical form and get it into exponential form. First thing is first. Now we can actually rewrite it also like this, 12 times, bringing this up into the numerator, you have 12x minus 6, and it's all raised to the negative a half. And I want to actually see something. Yeah, it's 12. Okay. It's a whole lot easier to take the derivative of this than use the quotient rule. I'm just going to tell you right now. Okay, I'm going to tell you that, and we're going to do that. We're going to take the derivative of this guy here, and the reason we're doing this is because there's just a constant in the numerator. If there was something that involved x's up here, then we'd want to use the quotient rule. But first thing, we're just going to do this. Okay, we got lots of time. Well, maybe we don't, but we're going to pretend we do. Right power rule, bring the negative a half, bring it out front, rewrite. I'm going to rewrite everything in parentheses. Subtracting 1 from the exponent. So a little side work, what is a negative a half minus 1? Well, isn't that the same thing as saying 2 over 2? That's minus 1, isn't it? And you got negative 1 minus 2 is negative 3 halves. That's negative 1.5. If this is 0.5 and we subtract 1 from it, right, you get negative 1.5. I don't know. However you want to look at that. And then we take the derivative of the inside and bring it out, and the derivative of the inside is just 12. Okay, so really we're almost done here with this problem. Let's go ahead and clean it up. We got y prime is equal to. Alright, so we have a half of 12, and a half of 12 is 6. right? And 6 times 12 is 72. So we have negative, and I'm going to leave this negative out front, 72 in the numerator. Now, instead of writing this with negative exponents, let's go ahead and take this to the denominator. So we end up with 12x minus 6 raised to the 3 halves power. Okay, raised to the 3 halves power. Alright, are you with me on all that? I hope so. Hope everybody's with me on that. That's a 3, by the way. Okay, now that's the fast way of doing it. You can use the quotient rule also. And you know what? I'm going to leave that as an exercise. You do it using the quotient rule. How's that? And yeah, I went ahead and hit the answer. Slowly scrolling down, holding my breath. Um, you need to go ahead and use the quotient rule. I'm not exactly sure. See, we're going to find the derivative in 2 different ways. Whoa, doggies. Yeah, we'll now use the quotient rule. So anyway, you use the quotient rule on that and see if you can come up with the same answer. Alright, there it is. Try both ways though, and I highly suggest that first way of doing it. Alright, and don't forget, you can come here and practice your problems. I'll see you there.